Thank you all for hanging in there through the day. I know this is the first full day of the conference and it's later in the afternoon, but I only have 5 minutes, so I'm going to go ahead and move right into the presentation. The concept of SHM probably isn't new to most of you since you've come to this conference from all over the world. But in a nutshell, if this is new to you or anyone viewing online at a later time, the concept would be that certain aspects of the bridge or a structural element such as a building is hard to monitor visually for certain phenomena. Those could include the current behavior, the long-term stability of your structure, and any event reaction that it encompasses after such a, like a seismic event. So one of the answers we have to this issue is to implement a structural health monitoring system. And what they do is they enable you to analyze data in real time, and they can also help you with both proactive and reactive maintenance on your structure. So what are some of the things that we would expect if we put forth the effort to install a structural health monitoring system? Sometimes you make assumptions during the design phase, so we might need some sensors or information to assess the real behavior or calibrate those models. A lot of structures here in the US are approaching the end of their expected service life, so we can use some of those sensors to monitor their aging, and we can also detect some hidden defects that can't be visually observed. Depending on the information that you're hoping to gather, you're going to make a relevant decision with that information. When you're designing a particular system, of course, the hardware or software will vary depending on the application. So normally an analysis is performed, a structural design, and the material of the structure will also impact the sensors you choose and the approach you take. Our experience is particularly with bridges. So there are multiple aspects of a bridge or a building that you can monitor. And for each of those, there are, of course, multiple types of sensors. This is just a list of some of the common sensor types. So here I have a video to show some of the types of monitoring implementations and structures that you may put sensors on. So this is a bridge in Greece. I'm going to let you watch the video. So depending on the sensors that you install on the bridge or the hardware that you put on your structure, there are certain outputs that you will obtain. Normally this is in the form of data, and you'll want to parse it or organize it in certain ways that's valuable to you. So here you, of course, can look at the daily, weekly, or annual data. And this is most useful if you have a visual way to represent it or observe it at a later point. Just CSV files or data files are not really useful unless you have a graphical representation of that information. You can also put these on some of the 3D models that you had originally used during your design assumptions and kind of set thresholds for automatic alerts. So here I'll go ahead and show one example of how you would actually use the hardware to react to a particular event. In this case, it's a seismic event on a bridge we have in Greece.
We are in Greece. Behind me, you can see the Rion-Antirion Bridge. It links Peloponnesus with mainland. The main challenge was to build this bridge in a high seismic activity area. Although this bridge is monitored with several sensors, At the beginning, we were not able to have a real-time analysis and a quick decision about traffic management immediately after the earthquake. For this reason, we developed a software. What we would like to achieve is to have a global picture of the structure. So we had to have in real time an analysis of a big volume of data acquiring from the monitoring system and to have an automatic decision in a short time after an earthquake.
We are in Rio Antirion Bridge control room. In case of an earthquake, an automated message is transmitted to the operator in this computer. The computer automatically processes the data and prints a report. This report contains a clear message of what the operator has to do. It could be from a simple inspection up to a bridge closing.
I'm not in control room, but I can have the alert report in my PDA. I know exactly the decision that has been taken from the software, and the same can be done for all the persons that are in charge of the bridge. The great benefit of this system is that this improves the safety, and for us the safety is utmost priority and concern.
And with that, thank you.